Assalamualaikum. Alhamdulillah. Good afternoon to everyone. Hopefully you guys have got your lunch, and most importantly, you guys have already performed your Zuhur prayers. Yang mana yang belum, I strongly advise for you to do so. This can wait, but your solat should be performed as early as possible. Okay. Hopefully you guys have got your lunch. Alhamdulillah. It's nice to see you again this afternoon, although I can't really actually see, though looking at your comments, that would do for now. So for everyone who already just entered our FB Live, our online quiz review, kindly comment to show that you are present for this session. Today will be a review on your quiz that you took on Thursday and Friday. So it will be a combination. Kita jamak kan, review quiz untuk part 1 dengan part 2 for today, since on paper we have a 2-hour session. So we will just have to make the best of our session today, so that tomorrow you can start with a new chapter, chapter 10, which is on electric fields. All the necessary materials have already been uploaded online, but only scheduled to be released tomorrow, because we do not want to burden you guys unnecessarily before the designated time lah kan. Sebab of course you have got other things to do as well. Tapi just a heads up lah, tomorrow will be your notes, and the feedback notes are due day after, which is on Wednesday. And on Thursday we'll be having our live session again to discuss on the questions as well as the necessary materials. And on Friday will be your quiz on the electric field. Hopefully this flow that we have already arranged would accommodate your learning of A-level physics. especially during this MCO ataupun RMO ataupun PKP condition. So hopefully you guys can hear me clearly. Can you drop a comment just to show that you can hear me? Tak tahulah kalau ada suara-suara yang di tepi tu yang mengganggu. Apologize for that. Tapi harap-harapnya boleh dengar my voice clearly. Okay, kita ada part 1 dengan part 2. Kita akan buat part 1 for 1 hour. Break sekejap, lepas masuk part 2. Okay, get ready your snacks. Untuk nak bertahan selama 2 jam petang ni. Yusof is here. Good to see you again after seeing you pagi tadi. Alright, so our class representative is already here. So we can start lah, insyaAllah. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Arrahmanirrahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. So the first part in superposition will be on standing waves, which is a second type of wave after progressive or travelling wave. So most of the questions are designed to gauge your understanding on standing waves, especially the calculations and interpretation of question. I think the last question for this online quiz is the hardest, but nonetheless, some of you did manage to answer it excellently. So I'm really proud of that, Alhamdulillah. So we just move on for the questions by question just to cover the materials, and if you have any queries or if you are unsure in any part during our review session, kindly comment on the comment section. We'll discuss it inshallah. Question number 1. These can actually be viewed also in the previous video that has already been uploaded in this group also. So dia macam buat 2 kerja 2 kali. But as of now, saya rasa macam okay lagi. Tapi I'm not sure. Probably it will help if you have other questions from different groups. Okay. So which of the statements about stationary waves is true? We've got 4 statements. So we just have to identify which one is true and which one is not. So dia kata a note occurs when the vibration is at a maximum. That is incorrect because a note is when the vibration is at a minimum. Part B, an antinote occurs when the vibration is at a maximum. Well, that's true. So automatically the answer is B, kan? Cumanya kita tengok jugalah all the other statements just to strengthen on our subject matter. So dia kata the distance between consecutive antinodes is 1 wavelength, and part D, the distance between consecutive nodes is 1 wavelength. So these 2 statements are actually incorrect because why? Consecutive nodes and consecutive antinodes only gives us half a wavelength, as you can see in the diagram or in the animation provided here. Okay, so just untuk nak bagi tahu dia salah lah untuk C and D, the answer is B. Okay. So question number 2, the diagram shows the fundamental mode of vibration on a string. The string is vibrating with a frequency of 60 Hz. Which diagram shows the third harmonic with the correct frequency of vibration? So there are 2 aspects in this question. Number 1 is the wave profile. Kita nak tahu during third harmonic macam mana bentuk dia dan berapa frekuensi dia. Alright. So this is the first harmonic which constitute to half a wavelength ataupun kita panggil 1 loop. Okay. Loop ni adalah dia punya dispute nanti kan untuk soalan the next question kan. Tapi In the meantime, kita just tengok kat sini. So kita ada one loop ataupun one segment ataupun half a wavelength here as the first harmonic for a vibration on a string. So for A and C, both of them are actually the second harmonic, which is what we do not want lah kan. We want the third harmonic. So the third harmonic is either B or D. So from here, kita nak calculate dia punya frequency. Is it 120 or is it 180? How do we do that? So well, we are given a frequency of 60 Hz. We are not given the length of the string. So what we can do here is actually the ratio, kan? So V is constant because we are using the same string. Is equals to F1 lambda 1 equals to F3 lambda 3. We know that lambda 1 is equals to 2L, although L is not given the value, but it's okay. We just use the ratio. So for the third harmonics, 3 lambda 3 over 2, which is 1.5 lambda, is equals to L. So lambda 3 is equals to 2L over 3. So we've got two values, persamaan serentak lah kan, simultaneous equations. So substitute into the ratio, F3 is equals to 180 Hz. The answer is D. Okay. So this is the answer. Substitute saja lah kan. Okay, 60 is the frequency at F1. F1 is equal to 60 Hz. So the answer is 180. Straightforward. Question number 3. Okay. The diagram shows the apparatus used to measure the wavelength of microwaves. We've got a transmitter and we've got a metal plate. So kat sini kita tahulah kalau dia ada transmitter, dia ada metal plate. So that means this experiment is to study standing waves. As a detector is moved from the transmitter to the metal plate, so detector dia tak lukis lah gambar dia sebab it is moving. Maxima are found at points P, Q, R, S and T. What is the wavelength of the microwaves? So kalau dia cakap maxima, we got either maxima or a minima. A maxima is that point would be an antinode. A minima is a node. Okay, sebab maxima is the maximum amplitude where the particles vibrate, but for a node it will be the minima because a destructive interference occurs during a node, at a node. So PQRS and T are antinodal points. 2 lambda is equals to 20 centimeters. How do we know it is 2 lambda? Because we can actually draw the wave. So here we've got antinodes here, antinodes here, antinodes. So PQRS dia ada antinode. So yang ni dia akan jadi 2 lambda lah kan? Betul tak? Tengok kat sini, tengok kat sini, and tengok kat sini. So this is one wavelength, and this is another wavelength. So 2 lambda is equal to 20 centimeters. Okay. How do you know it's 20 centimeters? Because you are given here not the length of P from P to metal plate, tapi dia P until T, and dia kata T tu adalah antinodes juga kan. Walaupun kita tahu anything yang sentuh dekat metal plate kat sini, dia akan jadi nodal point lah kan, sebab dia closed. Tapi kat sini kita just tahu dia ada maxima dekat points yang dia specify. So the distance given is between P and T. So that's why 2 lambda is equals to 20 centimeters. Alright. Welcome Alif Razak. Alif Razak is watching. So the answer is C. Part 4. Okay. Which diagram shows the fundamental mode of vibration in an open pipe? So automatically when we know that it is an open pipe, so at both ends must be antinodes. So this is wrong because yang ni dia bagi node dengan node. This is also wrong, node and node. At the end, this is an example of a closed pipe, not an open pipe. So the answer is B. Okay, straightforward. Part 5. A vibrating tuning fork held above a tube set up a standing wave in the air in the tube. Which of the following statements is correct? So it's between a node and antinode. Lepas tu dia kata vibrating tuning fork held above a tube. So if you can draw it, so we've got a tube kat sini, So the tuning fork, we draw it here. So they vibrate. The particles would oscillate kat sini. So kat sini dia akan jadi node. Kat sini dia akan jadi antinode. Betul? Alright. So a vibrating tuning fork vibrates the air particles within a tube air column. The air particles will vibrate to the sound caused by the fork in a longitudinal wave. So longitudinal, tapi regardless the direction of the particles vibrate back and forth, kan? Because it is a standing wave parallel to the length of the tube. So this is the length of the tube. So the answer is A. Okay, welcome everyone. I hope that the connection is okay. Kalau keluar masuk, we still have the video stored in our group. Okay, moving on. Subjective question. I think this one is straightforward. Boleh. Yang mungkin tough ialah part 2 kan, on diffraction. Okay, tak apa, kita cuba buat dulu. Alright. One end of a rope is fixed and the other end is shaken rhythmically. A stationary or standing wave is formed on the rope. Explain how such a wave is formed on the rope. Dia kata, the incident wave generated by the rhythmic oscillation would travel along the rope, and when it reaches the end where it is fixed, the wave gets reflected. So the keyword here is reflection. Although you need to specify lah kan, incident wave tu ialah wave travelling from the end yang dia shake tu, lepas tu kat mana dia start kena reflect, bila dia sampai dekat end of the rope yang fix tu lah. So from there dia jadi reflection. So interference caused by superposition between the incident and reflected waves at its natural frequency, of course, would form a standing wave. Okay, this concept is thoroughly discussed throughout this chapter lah kan, basis of a standing wave. Question 7. The diagram shows a stationary wave on a string. Mark the positions of the nodes and antinodes. So yang ni string. So kalau string dia fixed end, we got a node and node kat sini. So kat sini dia ada 4 nodes and 3 antinodes. Explain what is meant by a node and antinode. So part A is on the diagram. Part B is the definition. So you have to define a node is a point of zero amplitude. Tak ada apa-apa berlaku, ada lah, dia punya destructive interference happens at this point, but the amplitude is zero. So the particles do not oscillate at this point. What about the antinode? Maximum amplitude. Okay, so these are the main keywords lah yang you guys kena watch out. Okay, are you guys okay? It's awfully quiet here. Mengantuk tak mengantuk, I'm not sure, tapi it's good to have comments just to ensure that you are not sleeping, because if you are asleep then you can just watch the video from the previous group. The point of having this live session is for to discuss. Okay, tapi banyak soalan pula, nanti susah pula nak jawab kan. Okay, part C. Determine the wavelength of the progressive waves on the string. So kita tahu dia L equals to 75 cm. So we've got 3 loops ataupun 3 segments, where a segment is between 2 consecutive notes. I think Alif he discussed with me separately. Dia bagi apa? Dia bagi a good definition, dia good observation lah kan. A segment ataupun a loop is between 2 notes, 2 consecutive notes, which is half a wavelength. So kalau kita ada 3 loop, maknanya kita ada 3 segment, which is the lambda is 3/2. So this is a third harmonic string system. Okay, Arif tak masuk lagi Arif ada? Tak perasan lah. The wavelength for this third harmonic string system So we've got 3 lambda over 2 equals to 75 centimeters, which is the length. So lambda equals to 50 centimeters. Straightforward. You get 2 marks, guys. Okay, proceed. A string of length 80 centimeters is fixed at both ends. The middle of the string is plugged. Ni kalau Arif ada, dia boleh buat practical terus kan dengan gitar dia kan. Unless ada orang lain yang main gitar kat sini. Kirim salam kat dia. The middle of the string is plugged. Plug ni memang kena petik lah This creates a stationary wave pattern on the string with one complete loop. So I think segelintir of you assume that a loop is a full wavelength, betul? But it is not, right? It is just one segment. Okay. The string is vibrating in fundamental mode with a frequency of 20 Hz. Calculate the wavelength of the progressive wave on the string. Oh, Arif ada. Hopefully quiet today. String is at fundamental resonance, first harmonics. So lambda over 2 is equal to L is equals to 80 centimeters. From here you get lambda equals to 1.6 meters. Why is one segment a complete loop? Well, if you look here, assuming that we have a node here, and then we've got another node here. So this is one segment lah kan? And then you have a node here. So if you define a loop is when this particle goes back to its original place. That is the definition of a period ataupun definition of a wavelength kan. So that is for travelling wave. Tapi kalau standing wave, this particle within these two nodes, okay, dia oscillate in a way, in a manner in which between two antinodes, they oscillate up and down. So this actually have already created a one complete loop. Does not necessarily have to be one wavelength. So kalau one wavelength, dia dah jadi two loops lah kan. So disebabkan dia dah, all the particles here vibrate up and down, sufficient to say between two nodes is actually one complete node. Okay. Part B, the speed of the progressive wave on the string V equals to F lambda, F equals to 20 Hz. This is the lambda that you obtain, 1.6. So you get straightaway 32 meters per second. So if you use 160 centimeters, you'll get 3,200. So that's it. Okay. Question number 9. A tuning fork vibrating at a frequency of 490 Hz is held above the open end of an empty bottle. When the length of the air column within the bottle is 17 centimeters, a fundamental mode of vibration is set up in the air within the bottle and a loud sound is heard. Sketch a diagram of the stationary wave pattern. Assume the air within the bottle is a uniform cylinder of air. So this is the diagram. So the length is 17 centimeters. So dia closed pipe system. Closed column lah First harmonics. So first harmonics is a quarter of the original wavelength. Okay. So quarter wavelength equals to L. So lambda is equals to 68 centimeters or 0.68 meters. So part C is speed of sound in air. You know beforehand the speed of sound roughly estimatedly will be roughly around 300 to 330 meters per second, right? So you should get that value, that range, within that range of value in your calculation. Sebab dia tak buat eksperimen ni dekat negara yang ke-500 kan. Okay. B equals to F lambda equals to 490 Hz multiplied by 0.68 meters. So you use the wavelength that you obtain in part B. This is using the wave equation. So V is roughly approximately equals to 330. So you use 330 meters per second because it is two significant figures lah. As kalau tengok dekat semua data-data yang ada dalam soalan ni, 490, 17, so it's either 3 or 2 significant figures, tapi kat sini dia guna 2 significant figures. So here you use 330. But if you use 333 pun boleh, kita terima 333.2 pun. Question number 10. A string of length 1.6 meters is held under tension. When the string is made to vibrate at a frequency of 400 Hz, 3 antinodes are formed along this length of the string. Determine the speed of the progressive waves that form the stationary wave pattern. Okay. So, kalau kita ada 3 antinodes and dia akan jadi string. So, dia antara string ataupun open end. So, you have to define that. Kalau string maknanya both ends are nodes, kan? So this should be your string lah, which is kalau kat sini maknanya kita tahu it will be the third harmonics ataupun there are 3 loops of a stationary wave. The L is given 1.6 meters. So from this information you can answer the question lah, which is the speed of the progressive wave because you are given F. So first benda yang you kena buat apa? Cari lambda, betul tak? Lambda, 3 lambda over 2 because this is only one wavelength and you've got another half here. So 3 lambda over 2 equals to L equals to 1.6 meters. Lambda is 1.067 meters. So ada juga di kalangan you all yang terus bundakan benda ni to become 1.1 meters. So cepat sangat dia nak jadikan 2 significant figures. Relax dulu. Relax dulu, okay? Sebab nanti dia nak cari speed. This will be your final answer. So final answer baru you bundakan jadi 2 significant figures lah. Using the wave equation, V equals to F lambda, you can get V equals to 400 multiplied by 1.067. So the final answer is 430 meters per second, accurate to 2 significant figures. 430. Okay, this is the mark distribution. Moving on, question number 11. The diagram below shows a stationary wave pattern formed in the air between the open ends of a tube. So open pipe system, when a vibrating loudspeaker is held at one end. So the sound wave, the positions of the nodes and antennas are also shown. So alhamdulillah, information has already been given. The length L of the tube is 60 centimeters, although the speed of sound is given in meters per second. So watch out, here you've got centimeters, here you've got meters. Determine the frequency of sound from the loudspeaker. So dia bagi ke debu 5 markah. First, what you have to do, define as second harmonics of an open pipe system. Ada yang confused, nampak macam yang ni 2 lambda kan, tapi dia sebenarnya 1 lambda saja. So yang ni, ini. So 1 lambda sajalah, dia bukan 2. So calculating the wavelength, lambda equals to L, thus lambda equals to 0.6 meters. Given that V equals to 340, approximately, using the wave equation, you get frequency is 570 Hz. So that is the frequency in which the loudspeaker is operating at, 570 Hz. So ni semua calculation direct to the point. I guess you guys are actually, kalau lah setengah orang yang tengah menunggu untuk nak tengok part 2 kan. Sebab part 2 susah lagi kan dengan part 1. Nonetheless, kita cuba buat juga. Okay. Last question. So last question ni, yang ni some of you managed to answer. Excellent. Saya memang bagi remark excellent bagi siapa yang dapat, because this has got to do with what we call the end correction term dekat kita punya resonance tube. Okay, what is a end correction term? So let me just show you kat sini. First kita tahu tuning fork. This is the tuning fork vibrating at frequency of 256 Hz. held over an open end. Okay, there's a closed pipe system lah kan. It's a closed pipe system. A stationary wave can form in the air between the open end of the tube and the surface of the water. Okay, fine. Kita tahu lah kan. Betul lah tu. Okay. Then the antinode at the open end of the tube does not occur exactly at the end. Betul? Because there is a small distance between the tuning fork here and the mouth of the column ataupun the mouth of the tube. We call this as the end correction term C. Yang ni ada dalam you all punya notes, either in the slide ataupun in the mind map. Dua-dua ada benda ni. Okay. So it actually occurs at a small distance C from this end. The distance C is known as the end correction term. The value of C for a particular tube does not depend on the harmonic. Okay. This experiment takes into account any errors that may occur due to the end correction. Maknanya dalam you punya calculation kena ada C. The tube is fully immersed into the water. Right? The open end of the tube is slowly raised. Maknanya apa? Mula kita masuk, lepas tu kita hit the tuning fork, lepas tu kita raiskan dia punya tube tu untuk nak tahu bila harmonics tu muncul kan. So dia kata, a loud sound is first heard when the top of the tube is 30 centimeters above the surface of the water. So, kat mana dia punya 30 centimeters tu? Is it here? Or the entire length is 30 here? Ataupun is it just here? Jadi yang ramai orang confused. Okay. Yes, Kalisha, you asked, the antinode occurs exactly below the tuning fork. Yes, antinode tu maknanya sebab itulah dia akan ada lebihan sedikit. It is not exactly at the mouth of the tube, but it is actually occurring at the tuning fork because that is the source of vibration. Vibration occurs at the air particles vibrate actually at near the tuning fork. Okay, so the value of 30 centimeters kat sini mestilah dekat this one. So yang ni lah yang kita panggil L. So L1 is equals to 30 centimeters. The next sound, the next loud sound. So loud sound ni nak menunjukkan dia adalah satu ni lah kan, resonance lah. They hit the resonance frequency. Okay. Yang wujudkan harmonics kat situ. So the next loud sound is heard when the top of the tube is 95 centimeters above the water surface. So maknanya kita tarik dia punya tube tu lebih tinggi. Now, using this information, determine the speed of sound of air. So kita tahu speed of sound in air memanglah 300 meters per second roughly, betul? So that you should look out for. Okay, let me just give an example. This is actually apa eksperimen tu tengah buat. First, dia tarik benda tu. Okay. First, dia tarik benda tu. First harmonics occur at L equals to 30 centimeters. So, 30 plus C is equals to lambda over 4. This is the first equation kan. And then dia tarik lagi sampailah dia nak terkeluar, hampir nak terkeluar kan, 95 centimeters. Tapi dia tak beritahu lah sebenarnya the length of the resonance tube ni berapa, tapi tak apa. Yang penting kita ada dia punya distance from the surface of the water to the mouth ataupun to the mouth of the resonance tube lah kan. That is sufficient enough. C term ni memang kita biar saja because we don't know what is the value. Lepas tu dia kata it doesn't depend on the harmonics. So we just use it as a constant value probably. C, distance from the mouth of the resonance tube. So L here is 30, L here is 95. Cuma kat sini adakah it is the same harmonics? No, because it says here the first harmonics occurs kat sini. The second loud sound, which is the n equals to 2 harmonics, would be at L equals to 95 centimeters. Where kat sini kita tahu berapa wavelength yang dia ada. So this is half a wavelength. This is actually So it will become 3/2 lambda. Kan? Walaupun sini dia jadi lambda over 4. Betul ke? 3/2, sorry, it's not 3/2, it's 3/4. Okay, let me just betulkan yang tu. It's 3/4 of a full wavelength kat sini. Okay. Perasan kan? Okay kan? Boleh ke macam ni? So yang ni lah beza antara the first and the second. Okay. Going back to the question, now we can answer using both equations. Once we already nak fahamkan soalan tu satu hal kan. Fahamkan soalan baru kita boleh jawab. Okay. So the first sound refers to the first harmonics where lambda over 4 equals to 30 centimeters plus C. The second sound refers to the second harmonics of a closed pipe system where 3 lambda over 4 equals to 95 centimeters plus C. We do not know C, but we do not have to find out C. So you subtract the first equation from the second equation. Okay, you get lambda over 2 equals to 65 centimeters. Here you get lambda, and from here you should have no problem. Given F equals to 256, V is equals to 333, and you round off approximately to 2 ataupun 3 significant figures pun boleh juga. Sebab frekuensi dia bagi 256 kan. So you can give it as 333 meters per second juga. Okay. So the second one is third or second harmonics. Yang ni is exactly the same question that was asked in the previous group pagi tadi. Dia boleh jadi second, third, ada khilaf. Difference in opinions on how we define whether it is the second or is it the third. But the second loud sound, so easier to define it as the second harmonics because dia tak ada, sebenarnya dia third tapi dia skip second. Tapi technically for a closed pipe system kita settlekan second harmonic sajalah kan, sebab dalam notes memang dia bagi as second harmonics, so kita define kat situ. Okay. So that's where you get yes, we do not have, thank you Farah Adriana Sofia, since we do not have to find C, do we still need to write the C in our working? Yes, we have to put it down sebab just to show that we acknowledge the existence of the end correction term and to show that it is included in our analysis. Sebab kalau kita tak includekan dia punya value kat sini, C kan, kita akan just kata lambda over 4 equals to 30, 3 lambda over 4 equals to 95 kan. So kat sini dia not accurate lah. We are not acknowledging yang there is a end correction term, although it is dia tak kisah kan. Situ. Okay, I'm reading the comments. Kalau ada soalan boleh tanya. Alright. So this is the system. Moving on to the bonus slide. Before we proceed to part 2, rehat sekejap, minum. Siapa yang berpuasa, minta maaf. So we are 40 minutes in. So after this bonus slide, insyaAllah kita akan berhenti sekejap, take a breath, dan kita akan masuk discussion on part 2 lah, yang susah tu kan. Tapi kita masuk bonus slide dulu Alright. So now I'd like to share with you some reflection and this slide has something to do with part 2 jugalah in superposition, which is diffraction. Sebab diffraction lah benda yang macam susah kan untuk semua orang jawab. Ni part 2 je lah. Soalan apa lagi yang dia nak tanya kan. Tak apa. Okay, we recall the definition of diffraction. The definition is spreading of waves after the wave passes through an aperture or meeting an obstacle. So dia ada dua situation dalam diffraction kan, yang you boleh tengok dalam notes kan. Tapi yang penting kita tahu kalau dia tengah propagate travelling waves, when travelling waves it is propagating and suddenly in the middle of its path adanya aperture ni maknanya slit lah kan, ada a very small opening, or meeting an obstacle, what happens? It spreads kan, it gets diffracted. So here we've got three examples, three animations you can actually observe. Waves passing through an aperture, slit lah, with width, dia punya besar dia tu is actually D. So we've got D greater than lambda. If D is greater than lambda, so the diffraction can't really be observed. Kalau D is less than lambda, so we have a very good spreading lah kan, very good spreading. And then waves meeting an obstacle kat sini, the third one, this is slits lah, passing through slits, and here we've got obstacles. So here you know that this is a shadow region. So bila kita tahu dia ni shadow region, if assuming for example this is a sound wave travelling, so if you want to place your baby, baby kalau letak kat sini dia tak dengar lah suara. So tak semestinya you kena tutup baby tu entirely kan, just enough to block the wave from getting to the baby. So dia sebenarnya main diffraction ni lebih kepada dalam kita punya design lah, design mechanics, untuk nak tahu macam mana kita nak susun satu tempat dengan satu tempat yang lain. Alright, so this is what we are going to discuss in the next part lah kan. Okay, point to ponder. So this is the bonus slide lah kan. This should be our nature. Our nature apa? Bukan nature paper untuk nak publish science journal tu kan. No. But this, our nature ni maknanya kita punya tabiat dalam kehidupan. Number one, if we face an obstacle, okay, if we face an obstacle in life, our course will be affected, or in this case, term dia lah, diffracted lah kan. Yeah. But we still move. That is the nature of waves. We still move. It's not like it's the end of our life, it's the end of the world, and dah kiamat. No. Even in the hadith Nabi SAW, Rasulullah SAW said, if you see qiyamah and at that particular moment you have a tamar, you got dates kan, ada sebiji kurma, tanamlah dia. Kalau ikutkan dalam hadith lain. So that means any obstacle we face in life, we will still be facing it. We will be diffracted, but in the end, we will still move on. If we adhere to our nature of being a wave, it's not the end of the world. So naturally, dia akan berjalan dan sepatutnya hidup kita ni terus diteruskan. Apa-apa obstacle in life, nama pun obstacle lah kan, halangan dalam kehidupan. And if our path is closed, apa yang akan jadi? Kita akan reflected balik kan, kita akan jadi standing wave lah kan. Tapi with a very small window of opportunity, even a diffraction grating pun lah, diffraction grating yang dia punya magnitude tu 10 to the power minus 5 meters pun, even with that small opening of opportunity, aperture ataupun slit tu kan, it is still enough for us to pass through it and spread away. Maksud dia apa? With just a small amount of opportunity that we can see, that is sufficient enough for us to pass through the obstacle or the closed situation, for us to propagate, for us to move on with our lives. It does not have to be ideal. Setengah-setengah kalau yang OCD tu, dia akan affected kan? But no. Dia going through, dia akan berjalan dan berjalan. That is life. Okay? Macam sekarang ni, if you review your life, dulu waktu ambil PT3 rasa macam, oh itu dah benda yang paling besar. Tapi lepas dah habis PT3, move on. Bila habis UPSR, bila nak face UPSR, PT3 form 3 kan. Before that lagi kan, UPSR kan. Bila masuk darjah 6, masuk UPSR, waktu nak ambil UPSR tu rasa macam, oh itulah benda yang paling besar dalam hidup aku kan. Tapi lepas habis UPSR, okey je. Life goes on as usual. Bila PT3 pun, sebelum nak ambil exam tu rasa macam besar. Tapi after that, macam okey je. Bila nak ambil IGCSE tu, rasa macam besar. Tapi lepas habis tu, okey je. Dah siap jadi tiket masuk A-level kan. Masa ambil SPM sama juga kan. And if you think of it again, macam tahun ni kan, special condition, UPSR tangguh, PT3 tangguh, benda tu boleh berubah. Because of what? Manusia yang buat. So kalau lah benda tu boleh berubah, it's not really that important, betul tak? What is important is, ialah macam contoh kehidupan. Kerajaan bagi bantuan prihatin. You guys dapat kan duit kan? Berapa 200 kan? University students. Kira you guys dapat juga kan? I'm not sure. Tapi those type of sustenance need to be proceeded, betul tak? Tapi UPSR tak ada apa boleh tangguh. A-levels tangguh. Semua tangguh. Exams tangguh. So that means, kalau lah benda tu boleh ditangguhkan, so what is its value in life? It's not really that big. It's not really that significant kan? Kalau lah benda tu boleh tangguhkan. Food for thought. Tapi nak cerita ni, we tend to assume that it is an obstacle in life, betul tak? And if we review in the verses of the Quran, Allah SWT says in Surah Al-Inshirah, Alam nashrah laka sadrak wa wada'na anka wizrak alladhi anqadha zahrak wa rafa'na laka dhikrak fa inna ma'al usri yusra inna ma'al usri yusra fa idha faragta fansab wa ila rabbika farghab. Notice the words that I have bold. It says here, ma'al usri yusra. Maksud dia apa? For indeed, with every hardship. It uses the word every because it has, if you learn the Arabic language, this isim is isim makfirah. That means it is very precise, it is very, kita panggil apa, khusus. Khusus dalam bahasa Inggeris ni apa? Specialized lah, bukan specialized. Dia memang specific. It's very specific. One hardship. Allah SWT says, with one hardship, there's abundance of ease, yusra. So if you notice here, dia tak kata inna ma'al usri al yusra, tapi dia kata ma'al usri yusran. And if you learn the Arabic language, the tanween here, it says there's a lot of ease yang Allah SWT will give to you. For every hardship, there's lots of ease Allah SWT gives. And what is more interesting, Allah SWT repeats this verse again in the same chapter. Inna ma'al usri yusra. It shows that every obstacle we have in life is very small in the eyes of Allah Subhanahu Wa Taala. Every problem we face is either we do not have money. Of course, you guys probably tak rasa lah kan, sebab masih lagi student. Tapi mungkin setengah-setengah yang ada challenge, macam family challenge, ada rasa dia punya pressure bila mana PKP ni, your parents tak boleh nak keluar pergi kerja, especially yang buka business, yang terpaksa tahan, tak boleh nak keluar. So kalau tak buat business, tak boleh dapat income. So that is a hardship. But Allah Subhanahu Wa Taala has promised for every problem, for every challenge, every year, maknanya one, singular, there are lots of ease and there are lots of solutions in order to solve that particular problem. So this is the beauty of the Quran. And if we look back, actually this concept of diffraction beautifully describes how within an obstacle, the wave is actually moving away. Dia spread saja, dia berjalan saja. There's no problem. That should be our life. We shouldn't have any problems in our life. Problem tu akan ada, kan? Ujian tu memang Allah SWT akan bagi. But For what Allah SWT bagi ujian-ujian tu? Why Allah SWT give us all this type of obstacles in our life? Why? Because sebab Allah SWT sayang kita kan, contohnya kan. Because He wants us to be better and better every day, every day. Sebab kalau tak ada obstacle tu, kita akan duduk sama saja kan. Kalau kita tengok wave ni, dia akan ikut je kan, dia punya arus saja kan. Tapi bila keluar daripada slit tu, nampak kan, cantik je dia punya wave kan. Propagation of wave becomes much more beautiful lah kan. Sajalah untuk nak bonus slide just to share guys tu. But biasalah kan, for every bonus slide I give something, a question for you to ask yourself. Probably you can give me the answer jugalah. Kita tahu kita punya problems in life banyak berkisar as a student, masuk A-levels and whatnot. My question for you, what was the burden experienced by Rasulullah SAW and his companions? Was it near A-level exams and tests, quiz online, or internet problem, or yang memerlukan Allah SWT turunkan surah Al-Insyirah just to show that it's okay kan, for every hardship there's going to be ease. What was the problem that was faced by Rasulullah SAW at that particular time? Sampai tahap Allah SWT turunkan ayat ni. Just a comparison between us and Rasulullah SAW. Just for us to think deeply. Adakah kita punya problem yang kita rasa macam seolah-olah problem kita yang paling besar sekali dalam dunia ni kan. Semua problem orang lain semua kecil-kecil, kita je rasa kita punya problem yang paling besar kan. But comparing to Allah Subhanahu Wa Taala says, because this verse of the Quran is sent to Rasulullah SAW at that time kan. So what was the situation of Rasulullah SAW? And today we are actually reading this verse again, and of course this Quran has given to us. These messages of Allah Subhanahu Wa Taala is not particularly given to Rasulullah SAW, but it is also given to his ummah for us to read, and we have to ponder and reflect on the verses so that we could replicate what the Prophet ﷺ and his companions have already achieved. But in order to do that, we have to understand what was the hardship experienced by Rasulullah ﷺ and his companions. So that is my question to you. So insyaAllah, we'll take a break for 5 minutes and then we'll go online again, FB Live. Jangan ke mana-mana. Kita berjumpa lagi dalam masa 5 minit dalam kita punya group insyaAllah. Wallahu a'lam bissawab. If you have any questions, feel free to comment in the comment section ataupun dalam Telegram. Tapi nanti part tu kita akan masuk juga. Okay. So I'll see you guys 5 minutes. Assalamualaikum warahmatullahi wabarakatuh.